Welcome to my channel. In this video, we are going to look at the MTA applications of Oracle BRM. MTA stands for multi-threaded application. It's a framework available within BRM, and we can make use of it to build new custom MTA applications. So basically, the this particular framework is to build applications when we need to run or process millions of records. So, as the name suggests, it is multiple thread framework, which means that we can tune and configure the number of threads that we would like to process. And we can also configure how many records need to be processed by each thread. We can do all that configuration, and we can use this framework to process millions and millions and millions of records. So this is again a C function, C program that we need to write, but uh, it will use its own functions. So the first important thing to learn developing MT applications is to go through these framework details mentioned in this documentation. So you will be able to understand what is the use cases, how to write it, and then what are all the things that are available in the MTMTA framework. So basically, as you see, the first step is fetch some details from the database, and then process them, and finally exit from the application once you process. So we will go into the details. We will develop a program, and we will execute it and see how it works, and so on. So these are all the functions. Those are available as part of the MTA framework, and we need to make use of it. Uh, so let's go back to the presentation. So multi-thread applications, we have so many out of the box. OVB stands for out of the box. So there are so many out of the box multi-threaded applications available. For example, billing. What is the name of the MTA for billing, to run billing? It is pin billax, for example. So pin underscore BALL underscore ACCTS. That is the you can search for that in the documentation as well, and you will be able to find how to use it and what it does and all those things. It runs the billing. It bills the accounts. Similarly for invoicing, pin INVX, that is the MTA out of the box application which generates the invoices, or which creates the invoice objects in the database. And then of course we will use docgen, pininv docgen, or docgen process to generate the real PDFs that can be shared with the customer. So, and then payments, pin collect is the pin underscore collect is the out of the box application for collecting payments. There is out of the box MTA for adjustments. When we want to do adjustments in bulk, we have that. And there are so many others. Plenty of out of the box MTA applications are there. So whenever there is a need to process millions and millions and millions of rows or millions of accounts, then MTA is the option. MTA is the choice. We have to go with an MTA basically. It's like a batch program, batch processing application, we can say. And it will have a configuration file, which is similar to the configuration file for other applications like pin.conf. So we have discussed about pin.confs of CM and DM and other applications in the past videos. Similarly, MTAs will also have, each MTA application will have its own pin.conf configuration file. And there will be a make file. So make file is basically to compile the code, compile the application, generate the executable, and so on. So So these are all the components of the MTA. And then let's go to the next slide. So we need to understand the process, how MTA works, and then we can start implementing it. Then only we will know when to apply MTA, when to write, in which use case we need an MTA. That's the important thing to know. So if we have to, let's say there is a use case that we are creating an account and we would like to make some validations when before the account gets created. So can we use MTA for that use case? No, we cannot. We have to go with a policy opcode or a custom opcode in that case. So let's say we have a use case where we have a few accounts in the database and we would like to update the last name of certain accounts, or we would like to update the zip code of certain accounts based on certain criteria. Then what is the option? Then the MTA is the option. Multi-threaded application is the option, because we have definitive number of accounts which we don't know. Like there could be 1,000, 10,000, or 1 million, and then we have to uh, fetch them, process them, and then finally apply the changes. So the first step is the extraction. We need to extract. We need to extract from the database based on certain criteria. So it could be all the accounts from the database, for example, or active accounts from the database, or it can be any other search criteria, basically. So it depends on the requirement. So it is very important to identify the requirement before start developing. So the first thing is like a search template. Um, so basically MTA accepts two kinds of extraction. It can fetch either from the database using a search template, or we can also provide an input file as a data, as the criteria of the data. So let's say we have a certain definitive number of records that we want to process. So rather than fetching those from the database, we can provide it as an input file to the MTA. So both options are available for an MTA. Either provide an input file or define a search criteria. So when we define the search criteria, the MTA fetch the records based on the search template, and then after that, once it has all the records in place, it will fetch based on the uh, parameters configured in the config file that we will see. And finally, there will be a process to apply those changes. For example, let's say our requirement is to update the zip code for certain number of accounts, or certain accounts which are created last year or this year. Let's say if that is the criteria, then we will extract those accounts using a search template. We will go through, MTA will loop through based on the configuration, how many number of threads and all those things. And then finally it will apply the changes like updating the zip code, for example. So it does all the steps. So the next thing is these are all the 27. These are 27 functions available. We need to make use of these functions. We can write more functions, but it is always better to keep all these functions in the MTA and write code within these functions. So, uh, so for example, in the previous slide we saw that extraction is the first step. So what is the function that we can use to do the extraction? That is nothing but pin MTA init search. So init search, in the init search function, we will define the search template. And then after that, there will be a worker opcode function, which does the actual job. Like, for example, updating the zip code. If that is the requirement, then we will define the opcode there, provide the input of list for that opcode, and then it will does the job. But why we have so many other functions? So there can be so many other requirements where we have to do so many validations for the before even we process the search. Like we have to do a config if we have to do if we have to pass some parameters to the config, and usage is like MTA also accepts input parameters. So while we executing the MTA, we can pass the input parameters like the start date and end date, uh, for example, or let's say account status. If we want to, let's say we don't want to fetch all the active accounts from the system, but we would like the user to define the status. Maybe the user wants to fetch all the active accounts. Maybe next time they would like to fetch all inactive accounts. So we don't know which status of the accounts that user would like to fetch. Then in that case, we have to use the input parameters for the MTA. So MTA accepts the input parameters as well. So, but the basic blocks are these init search in most of the scenarios. So in general, we don't pass an input file. In general, we don't pass a lot of input parameters. So in that case, the basic blocks that would need to build a simple MTA will be init search and worker opcode. That's it, nothing else. Um, so as we discussed, the starting point to develop an MTA is build the search template, test the search template using test snap separately. Once the search template is working fine, then come to the MTA. Then come to the then start building the MTA application. So first, finalize the search template, test it using test snap, make sure it is working as expected, and then after that you can start building the MTA application. You can also test the opcode that you would like to use in the worker opcode. For example, let's say you are updating the zip code, then maybe you may use PCMOP right fields opcode. So test the right fields for one record and see whether it is working or not. Uh, and then you can pass those opcode related information in the MTA. So let's go back to the VM and see how to start writing an MTA application practically. So first thing that we need to do is go to the VM. Go to the cd pin home source apps. So MTA underscore sample is provided by default. When we install BRM, this will be there by default. So we can make use of it. We don't need to write from line 1. We can make use of the code available in this test folder. So I'm just going to copy pin mta test.c to pin mta, let's say sample.c, and then I'll open the pin underscore mta sample.c. So this is the code provided in the pin empty underscore test. So as you can see, these 27 functions are configured. So this function is trying to look at the the parameters that are passed to the MTA. We can either ignore it or remove the code that you don't want to see in your MTA. Better to remove the code so that it will avoid the confusion. Um, Remove that particular code that you don't need in each function. So I'll directly go to since this is the simplest application that we are trying to build, I'll go to uh, the extraction function. So the extraction will happen based on init search. So as you can see here, um, so here there is something like select star from data. Instead of data, I will try to put account. So the requirement that I'm considering here is fetch all active accounts from the database. Um, and then I'm not going to update anything to that, but I will just show you how to do that extraction. And then I'll show you the opcode where to put in the worker opcode, but we are not going to change anything for that opcode as part of this program, but the code wise we will place it. So let's say here I'll make use of this I to denote active status. 10100 is the active status of the account. So similarly, this is like a comment. This is the comments. This is the best practice to show what is your search template, how the search template will look like within the comments. So it's a best practice of coding. So then let's go to so here as you can see we are preparing the search template and then adding the flags to the search template. So probably I will use the flags instead of 0. I will use 512 flags, 512, and then coming back to so we don't need the previous functionality that is mentioned here. So I will try to comment all of this. And we are setting but we need to set the status for the argument. So for that we need to, instead of header num, I'll say status. So instead of the header num, it is going to set the status for the account, and that's it. So as you see here in the init search function, there is no calling of the search opcode, because since the functionality of this function itself is to do the search based on the template we provided, we don't need to explicitly mention do a PCM OP search. So there will be no PCM OP search opcode mentioned in this function. So that's an important thing that you need to see. And directly we will go to the worker opcode. So in the worker opcode, the main thing happens. See, for example, in this example from where we copied the code, it is trying to call the opcode called PCM OP INC fields. So here I am highlighting that particular line. So it is trying to use this opcode to update. So this is like the third step, which is applying the changes. So I don't want anything to happen as part of this. So I'm going to simply comment everything from here. So let's say I'll comment this. So multi-line comment, probably you might already know what is a multi-line comment. So I'm going to use the multi-line comment here. And we don't want all of this code as well. So I'm going to do another round of multi-line comments. So I commented until the actual execution, and that's it. We are done. Now go to the make file. So in the make file, we need to make sure our app is being compiled. So here there are some inclusion files, and there is a mention of the app name here. We need to make sure that in MTA our app name is sample. So this is the app name is nothing but the executable. We will be executing it every time when we need to run this particular MTA. So similarly, change the name of the C file. This is the C file that we have just created, and the object file. When we compile a C file, there will be an object file that will be created, as you all know. So that's it. There is nothing else that we need to change here. Let's try to compile. If there are any errors, then we need to fix it. As simple as that. 395, line number 395, there is an error, so we need to fix that. So where do we see the line numbers? We see the function name here. It says in this function pinempty init search, and then this is the file name pinempty sample.c file, line number 395. Error is expected something before this token. So we need to go to the file, open this file. We already done VI. Then we will go to the line number 395 directly. 395. Okay, so we commented the before line but not the after line. So we did that now. There shouldn't be any errors. No. Okay. So we have done the two steps. So search criteria we identified, and then we have edited the C file. I mean, we have created the C file and modified the functions. After that, we have modified the make file as well to do the compilation. And next step is, let's take a look at the configuration file of the MTA. So this is very important. We might always need to do the tuning based on these four parameters. So these are the four parameters. These values will be changed. We need to change it based on the environment. For example, if it is a dev or test environment, there won't be much resources like random access memory or not enough available memory. It cannot take up too many threads. So we need to use this simple configuration in the dev and test instances. But when it comes to the production or similar production or pre-production kind of instances, we can tune it. We can change the children to 20 and so on. Let's take a look at what is children. Here the definitions are clearly mentioned. So children is the number of threads used to process the accounts in the application. So let's say we are trying to process 10,000 accounts. So 5 child based on this configuration, 5 child, each one will process 1000 accounts. And in each batch it will process 500. After every 500 it will do the commit to the database. So the simple formula is number of child multiplied by number of per step configuration should be less than or equal to fetch size. If you try to put instead of 1000 here 2000, then 5 multiplied by 2000 will become 10,000, which will be more than the fetch size. So that is not an ideal configuration. This is the formula that we need to remember, like number of child into number of per step should be less than or equal to the fetch size. And this per batch should be less than per step. So if you see the definition, per batch is nothing but number of accounts processed by each child. So each child will take these many. Per step, number of accounts returned in each database search. So number of accounts, uh, uh, it will try to fetch from the database search every time. And fetch size, finally the fetch size, number of accounts cached in application memory before processing starts. So in this case we mentioned 5000. So it will first fetch 5000 accounts into the memory. It will keep in the memory and then it will start processing 1000. So 1000 will be given to these 5. Then each child will actually process 500 and then do the commit to the database. So 500 once and then another 500. It will complete its 1000. Once the 1000 is completed by the first child or any of the child, then it will exit. The child will exit the processing. So there is something called respawning. That means we can make use of these if we want to spawn it again. Uh, so in case if any thread got exited due to an error, then it will try to respawn. So it's a different use case, but this is the important configuration that we need to understand how MTA works, because this defines the performance of the application. If there are millions of records, then we need to tune it in such a way that the application will process it pretty smooth without any errors. So other than these, there will be a log level. Log level, I set it to 3 for now. And similarly, there will be a log file. So we can set the log level. If it is 3 means it will print everything. Log level 3 will be useful, ideal for dev and test environments where you would like to debug the application in case of errors. Similarly, this is the place the log will be written. So these are the important things, and then similarly look at the host name, which host it is trying to connect, and so on. So these are all the important configurations within the pin.conf for an MTA that we need to remember. So let's go back to the log directory and look for the application. I will clear the log, then go back to the cd pin home. So when we did the compilation, we got the executable. So this is the same how we execute any other applications within the Linux distribution or Unix or operating system. So dot slash, and then I'm going to paste it. Verbose will be there by default for everything. So as you see here, there are fetched units per step 12, but we actually mentioned 1000 in the configuration, but it only fetched 12. That's because there are only 12 records in the database. So, so that's about it. It is not doing anything in reality, but we need to see why it is hanging here. It should exit by now already. Um, if you see, there are 5 threads that are started. Thread number 1, 2, 3, 4, and then finally 5. So because in the pin.conf we mentioned 5. I aborted it. We need to see what exactly is happening, why it is not exiting. If there are any errors in the log file, this is where we can see. Um, so there are no errors, and let's see if it already fetched those 12 accounts. Yes, it fetched, as you can see here. Uh, account 1, 2, yeah, there are so many other accounts it is trying to fetch. So you can also see the search template. Select X from account where F1 equal to V1. F1 is nothing but the uh, status. So for active accounts, it is going to fetch. As you can see here, pinmta search F list is printed here as well. So this is how we can define the extraction criteria, and as you can see, the 12 accounts that are processed. Step next. So if you see here, the kind of search it is using is step search. So MTA uses step search to fetch the results, and these are the 12 accounts it fetched. And finally, we are not doing anything in the worker opcode, so it should exit ideally. So that's about the MT application, log file, config file, and make file, um, and execution. So this is how we execute it. Dot slash executable name, and then hyphen verbose is the default parameter that we have. And is there anything else that we need to look into? So within the worker opcode, I have commented, just trying to make sure I have commented everything here. Yes. In case if we want something to happen in this MTA, then this is the place that we need to mention. Like, what is the opcode name? What is the input F list to this opcode? And like, what should be updated here? For example, if we want to update a zip code, then we need to write the input F list. We need to update the input F list, and then pass the corresponding opcode here. So this is all about the MT application. And then if you have any clarifications, let me know. Thank you.